The serial option card gives you a way to communicate with any GSD8 DC Digital Drive over RS-232 or 45 that supports option cards. That means you can control and monitor anything available in the drive from a PLC, a SCADA system, or even your personal computer. It also has an analog input that can be configured to use a potentiometer or resistive input, a voltage input, or a current input. The analog input can be used to control the target speed and percent speed. It can serve as a tachometer input or a leader tach signal, and it can control a frequency generator output pulse rate. The frequency generator output pulse rate can reflect the analog input level, the motor speed, a fixed rate which is set in parameter 5032, or a status of the alarm output. There's a 2-pin header that can be used to control where the speed reference comes from, manually via the front panel or automatically from this card, which could be the analog input or the serial channel. Let's do a quick example of how to set up the serial comms. I'm using the same setup that we used in the previous videos. I have this GSD8 drive connected to this motor, which has this encoder, which goes back to the drive to complete the feedback loop. I also have jog and inhibit wired, and an indicator connected to the alarm relay output. Before plugging the COM card into the drive, I wired a switch to this auto manual terminal, made sure the RS-232 RS-45 jumper was set for RS-232, and plugged an Ethernet patch cord into the RJ45 jack because I find it's easier to do that with a card outside the drive. Now I just plug the card into option slot 500. Slot 500 is the only slot the serial COM card will work in. When you apply power to the drive, you see a message in the display asking if you want to configure the COM card. Press up arrow to do it. Let's go to parameter 95 and enter a 5 to reset our drive, so we're starting from a known configuration, which defaults to rate mode. Up arrow to confirm. And let's also reset the COM card to factory default, which is parameter 96, and we want to reset the card in slot 500. Up arrow to confirm. That's it, we're ready to go. To keep things simple, I'm going to use my desktop computer to talk to the drive. It doesn't have a serial port, so I use this USB to 232 converter, a female DB9 connector wired like this, and this ZipLink RJ45 breakout board, so I could easily wire my serial data into the drive's RJ45 cable. Now this wiring diagram only works if you have a straight-through RJ45 patch cable. If you have a crossover cable, you'll need to modify the wiring accordingly. Let's go to the device manager on his PC and make a note of which COM port the USB to serial cable is using. Okay, you can use any terminal emulator program you want. I like this Terraterm program because it's quick, it's simple, and it's free. But it's not an Automation Direct product, so please don't call tech support asking how to use it. They won't be able to help you. Just make sure that whatever terminal program you're using is using the right COM port. We're using this one, yours will probably be different, and that the port parameters are set to 9600 baud, no parity, 8 bits, and 1 stop bit, because that's what the COM card defaults to. This is how I have my terminal program configured. If I type in an AS01 and hit enter, the drive returns the actual speed, which is 0 right now. So I'll increase the speed a bit, and then type AS01 again, and now we see the new drive speed. There's only 6 commands. SP is set target speed, SV is set variable, RV is read variable, AS get actual speed, TS get target speed, and AL is the alarm state. They all start with a 2-letter command, followed by a 2-digit address. That's the address of your COM card, which is in parameter 5020. The default address is 01. And yes, you do need to include the correct address even if you're only using RS-232. The address is always followed by a comma, and however many parameters that command needs, also separated by commas. A final carriage return finishes the command. We're currently at this speed, so let's try to change that with the set speed command. At address 1, and let's set the speed to 250 RPM. Hit return, and we get an N. The N says the command wasn't executed, which we know because the drive speed didn't change. What happened? Well, the drive is currently in manual mode. It's expecting speed commands to be entered manually from the front panel. We can see that because this blinking LED is telling us we're in manual mode. It's blinking to warn us that we have a COM card installed, but the drive's in manual mode. To fix that, we need to go to parameter 120 to change it to a 2 to tell the drive that the option card in slot 500 will control the auto manual mode. Scroll to 0 and press Enter to exit the parameter entry mode. Let's do a read value from device 1, parameter 120. Yep, it's a 2 now. I'll flip our auto manual switch to auto, and look, the LED is now solid, telling us we're in auto mode, and the drive stopped. That is because we haven't entered a speed in auto mode yet. So now if we do a set speed at drive 1 at this rate, the drive responds accordingly, and we got a Y to confirm that the drive executed the command. Let's get the target speed from device 1. Perfect. By the way, if you send a command to the wrong address or send a bad command, nothing happens. You don't even get an N. Send the correct command, and everything works again. Okay, let's set variable at drive 1, 5020 to a 2. That'll change the drive's address to a 2, and we see we got the confirmation Y. Now if I try to get the actual speed of drive 1, we get nothing. But if I get the actual speed from drive 2, we do see the speed. Let's read variable from drive 2, parameter 1, which is the model number. And there it is. So that's it. You can now control and monitor anything you want in the drive using just 6 commands. And all we did to set that up was reset the drive, reset the option card, and tell the drive which option card was in charge of the auto manual function. By the way, you can also switch the auto manual mode by double-clicking the Enter key if you set parameter 18 to a 5. That's a handy thing to know. Now as a side note, I like to use an O-scope to debug my serial comms. So since I had it set up, I thought I would share it with you. Here you can see each character as I type it, and when I hit the final return, you see the reply from the drive. Looks like on my system, the response time is around 7 milliseconds. You might need to know that when you're programming your controller. Which reminds me, there are example programs for both the bricks and the productivity PLCs in the back of the COM card manual. This option card only adds 11 parameters, so go take a look at them to see how to set up the analog input and the frequency generator. Well, that ought to be enough to get you up and running with the COM card on the GSD8 family of digital DC drives. Click here to see all of the videos in this playlist. Click here to subscribe to our YouTube channel so you'll be notified when we publish new videos, and click here to learn about Automation Direct's award-winning free tech support options.